Hi, my friends. I'm Asad Jai Thakur, pursuing PhD from Indian Institute of Technology, Tirupati. Now, I will tell you what is probability and how probability is defined in statistics. It is a very important topic in statistics. To start probability, first I should define some terminology. Number one is sample space. Sample space is a set of all possible outcomes of a random experiment. Generally, it is denoted by capital omega. Sample point, it is an individual element of a sample space. It is defined by small omega. Event, it is a set of sample points for which a given statement is valid. It is nothing but a set. It is a subset of the sample space omega. Now I have to define the two terms. What is class of subsets and another is power set. Class of subsets is any collection of subsets of sample space omega. Generally, it is denoted by script A. In power set, it is the class of all subsets of the sample space omega is called power set. Now I am trying to define power set of omega mathematically. It is a set of such A's which A's are the subset of the sample space omega. Now I am trying to define two more terminologies. One is algebra and another is sigma algebra. These two are important tools for defining probability mathematically. Algebra is a collection of sets which is defined as script F. It is a subset of power set of omega, which is defined as script P of omega. It is called an algebra if it satisfies the following properties. Number one, omega, which is defined as sample space earlier, should be belonging in script F. Number two, phi, which is defined earlier as null set, should be belonging in script F. Number three, if any arbitrary set A is belonging in script F, that implies complementation of A should be belonging in script F. Number four, if any arbitrary two sets A and B is belonging in script F, that implies union of A and B is belonging in script F. That means algebra is closed under complementation and finite union. Now I am trying to define sigma algebra. Sigma algebra is an algebra which is satisfying one more property. What is the property that? The property is if an, which are the sequence of sets, if the sequence of sets is belonging in script F, that implies countable union of an should be belonging in script F. That means the difference between algebra and sigma algebra is algebra is only defined in countable unions. Algebra, that means algebra is closed under countable unions, but sigma algebra is closed under countable unions. So here lies the difference between algebra and sigma algebra. Now I will tell you a new terminology, that is measure. To define measure, two terms are required. One is sample space and another is script F. Omega is sample space of an random experiment, and script F, which is algebra, which I have already defined, and algebra script F is defined on the sample space omega. Now I am trying to define a function from script F to closed interval 0 to infinity. That means positive real line. And I'm giving name to F is measure if the F is satisfying the following three properties. Number one, F of A is belonging in closed interval 0 to infinity for any A who are belonging in script F. Number 2, f of phi is equal to 0, where phi is defined as null set. Number 3, for any disjoint collection of sets A1, A2, A3, etc. who are belonging in script F, then f of countable union of An is equal to sum over f of An. The sum is not finite. Here n is 1, starting from 1 and goes to infinity. Now I am trying to define the most important term in statistics, that is probability. For defining probability, similarly, two things are required. One is the sample space, that is defined earlier as omega, and another one is script f, that is already defined as sigma algebra. On omega, a set function p on script f is called probability, where p maps from sigma algebra script f to closed interval 0 to 1. If we are looking the two definition, one measure and another probability, then we have understood that measure is can be defined on algebra or sigma algebra, but probability should be defined on sigma algebra. Probability of A is belonging in closed interval 0 to 1. For all A is belonging in script F. Number 2, probability of phi, where phi is defined as null set, is equal to 0. Probability of omega is equal to 1. Number 3, for any disjoint collection of sets A1, A2, A3, etc., who are belonging in script F, for those AIs, probability of countable union of AN is equal to sum over n probability of AN for those AN who are belonging in script F. So what is the basic difference between probability and measure? Measure, the range of measure is closed interval 0 to infinity, but the range of probability is closed interval 0 to 1. That means probability is a finite measure. Now I will try to define some properties of probability and measure. First property of probability and measure is monotonicity property. If A is a subset of B, that implies probability of A less than equal to probability of B. Similarly, if A is a subset of B, then if A is less than equal to if B. Number 2, subadditivity property. If A is a subset of union over AN, then probability of A less than equal to sum over n probability of AN. Similarly, f of A less than equal to sum over n f of AN. Number 3, monotone continuity theorem. If AN is a monotone sequence of sets, monotone sequence of sets means either the sequence of sets is non-decreasing or non-increasing, such that AN is belonging in script F, then limit n tends to infinity, probability AN is equal to probability of limit n tends to infinity AN. Similarly, in measure is limit n tends to infinity f of AN is equal to f of limit n tends to infinity. Now, I am trying to give an example to get better understandings on the sample space, sample point, algebra, and sigma algebra, and power set of omega. Suppose a coin is tossed twice, then the set of all possible outcomes is 2 times head, first time head and second time is tail. Third point is first time tail, second time head, and the last element is 2 times 10. And I will try to define these 4 elements as omega 1, small omega 1, small omega 2, small omega 3, small omega 4 consecutively. Now I am trying to define a sigma algebra that is denoted as script F here. It is the set, but the first element is phi null set. Second element is only small omega 1. Third element is the set of omega 2, omega 3, omega 4, and the fourth element is capital omega. If we look at this, then we will understand that script F is sigma algebra because of number 1, phi is belonging here. Number 2, capital omega is belonging here. Number 3, as small omega 1 is belonging here, the complement of small omega 1, which is the set of omega 2, omega 3, omega 4, is also belonging here, and the union is also belonging here. So that's why script F is sigma algebra, undoubtedly. Now I am trying to define an algebra. Script A here, it is the set, but the first element is phi, second element is omega 1, third element is small omega 2, fourth element is small omega 1, comma small omega 2. If we look at this example of algebra, then we see pi is belonging in algebra, omega is belonging in algebra. As omega 1 is belonging, small omega 1 is belonging in algebra, then the complement of small omega 1, that is small omega 2, is also belonging in algebra, and the union of these two elements is also belonging in algebra. That's why it is closed under finite unions and complementation. In the complementation of omega 1, omega 2 is omega 3 and small omega 3 and small omega 4. That is also here. And the union of that element and that element, that is capital omega, which has already belonged in the set 50. That's why algebra is closed under finite unions, complementation, and phi and capital omega has been already belonged here. So it is undoubtedly satisfying the all properties of algebra. Now I'm defining power set of omega. As omega has 4 elements, that's why power set of omega has 2 to the power 4 elements, that is 16 elements. That means if a set has n elements, then the power set of that set has 2 to the power n elements. It may not indicate that power set always has finite number of elements. It may possible that cardinality of power set is infinite. Now, the next slide, I am trying to define probability. A1 here is null set. That's why probability of A is equal to 0. A2 is sample space, that is omega, and probability of A2 is 1. A3 is small omega 1, which is headed, and probability of A3 is 1 by 4. A4 is small omega 4, that is 2 times 10. Probability of A4 is 1 by 4. A5 is A3 union A4. Then probability of A5 is 2 by 4 because A3 and A4 are disjoint. And probability of A3 plus probability of A4 is also equal to 2 by 4. And one more observation is, as A3 is a subset of A5, then probability of A3 less than probability of A5. That means probably the example also indicates that probability is satisfying the monotonicity property. Now I will tell you the classical definition of probability. The probability of an event is the ratio of the number of favorable cases of an event to the number of all possible cases. If we look at the example, then probability of A4 is equal to cardinality of A4 divided by cardinality of sample space omega, that is 1 by 4. That means probability is a fraction where numerator is the number of favorable cases of an event, that is A4, and the number of favorable cases is here only 1, and the denominator is number of favorable cases for all possible cases, and that is 4. That's why the fraction is giving the result 1 by 4. So it is clear that probability is nothing but a ratio or fraction of the number of favorable cases of an event to the number of possible. Okay, now I am ending here. The next lecture I will come with conditional probability and independent probability. Okay.